welcome to this last week of lectures in the MLOps course. In this week, we will summarize the main best practices for the entire gamut of topics that we've discussed under MLOps. Then we will dive into some additional topics which are more emerging in this field. And in that, we will cover just a couple of them which are of interest to us. And obviously, there's going to be a lot more, developments that will happen in these fields much beyond the lifetime of this course. So, I encourage you to stay abreast of what's happening. And then towards the end, I'll just give my closing thoughts on how you can take some of these learnings and apply it in your own work, uh, keeping in mind the broader arc of evolution as AI systems become more mature and intelligent. So let's start with a summary. I think we took a look at this particular slide in one of the first 2 or 3 weeks. I find that this slide actually captures the essence of machine learning a lot better than many of the discussions around data science that some of the other courses do. So let's walk through this so that we understand this. When we first encountered this slide, I think most of you were not exposed to the level of operation complexity and detail that you eventually ended up getting exposed to over the next few weeks in the current course. Now that you've seen close to 11 weeks of different topics pertaining to MLOps, I think it's a good time to revisit this and gauge for yourselves whether what you saw in practice was what you actually you know expected to see when you first began this course. So the steps outlined here are the classical machine learning workflow, starting off with feature engineering, then you go through model training and selection, then the publishing of the model, especially as a pickle file or as an API or as a container. Then the model gets used, which is the act of scoring, and usually this is done in an online fashion. Then you continuously monitor that for bias or drift, etc. Retrain as necessary. Then publish the model that you've finally chosen as the challenger model once these iterations of model training, selection up to retraining finishes. Finishes meaning satisfactorily as per some kind of a performance metric you might have. And then when the challenger model gets published, then you start to experiment with both the challenger model and the champion model that's already running. And you load balance the traffic so that both these models get tested out, uh, essentially what's called as A/B testing. And then eventually you will like the challenger model or not. If you don't, you discard. If you like it, you promote it, and it becomes the next champion. And then the cycle continues as the data set evolves, etc. What did we see during the course of this course is the fact that a lot of the steps associated with MLOps are the steps that you see in the box, the colored box, and specifically the text in red pertains to when human inputs are absolutely necessary. It's not to say that the human inputs are not necessary for the other steps, but if you have sufficient level of automation and if the problem statement is not dauntingly complex, you could do automation for the other steps like model publishing, monitoring, etc. So if you look back at the course itself, we spent a lot of time understanding these steps that are there in the colored box, the tools associated with them, the extent of automation that's possible, and then tied it back to the entire model development lifecycle. So I hope that's the essence of what you've got from this course. So specifically, model training and selection, while we didn't necessarily solve a brand new data science problem, which had its own feature engineering challenges or model selection challenges, we spoke about how the aspect of operations can aid this step, which is specifically around hyperparameter tuning, experiment tracking, etc. Then the act of publishing itself is something that we spent quite a bit of time on. You've learned how to use a really, you know, uh, sophisticated tool like Kubernetes for getting your model across into production. and not have to worry about it not scaling for higher velocities or higher volumes of data. Um, so containerization is something that you've really mastered, I hope. There are a lot more aspects to mastery, obviously, but then we've taken the first few steps, I should say. Model scoring is obviously beyond the purview of this course. It depends on the model, depends on the problem statement, but we definitely spent a bit of time looking at how that score changes over a period of time and what can you do about it. How can you monitor it in the first place, especially when you have multiple components to the system. It becomes a really daunting challenge to tie logs from all of these components together so that you have an effective monitoring system. And we saw how with Google Cloud we could do that. Obviously, there are open source tools. You will hopefully get exposed to them in your real world practice. Retraining as necessary. So, invoking retraining. One particular topic that we didn't spend a lot of time on was this concept called AutoML, automated machine learning. While it suggests that it's automating machine learning, really it's not doing all of that. It's automating salient steps, especially around model selection, given a feature engineered set of data. It automates some aspects of feature engineering, the ones that are domain agnostic, and it also automates the hyperparameter selection process, like how do you navigate the plane of hyperparameters. And I think it's a very useful automation aid in step number 6 especially, but don't depend on that for completely automating 6. You still need a human input. You still need guidance to how and when you find that a particular model should be selected finally. Publishing the models into APIs, doing experiment load balancing, all of that was hopefully something that you got a glimpse of based on um, the Kubernetes setup in Google Cloud, where you can take the load balancer IP and split the traffic, etc. We didn't do the splitting of the traffic ourselves, but it's very easy to do. I encourage you to read up about that online. And then finally, the promotion of the challenger is something as simple as just enabling 100% of the traffic against that API. Okay, so in that summarizes ML in practice. It's a very useful set of steps that you can keep in mind, or you can keep this as a ready reckoner when you want to look back on this reference. Okay, so we also spoke about how the choice of how you do development really impacts operations. Specifically, when machine learning models are developed, you really need to think in terms of 3 different environments. One is the developer environment or dev environment. The second is the staging environment, where you get access to uh, more production grade data, um, not just samples, and you get also access to the full production paraphernalia in terms of operations, so that you know for a fact that something that works in staging is very likely to work in production. And obviously the prod environment itself. And we spoke at length about why for typical machine learning problem statements, it's best to follow a deploy code pattern. What this means is the code that you write for building the model and deploying a model into an endpoint or into a container, that is the artifact that moves across these 3 environments. The reason it's best is it's tested, it works, and you're trying to limit the number of variables which are not under your control, such that when the production deployment happens, the chances of something going wrong is significantly lesser. And the acknowledgement is also there that the production grade data is not going to be the same data that you get in dev because of privacy reasons. So how do you ensure that the model that gets trained is also accurate, but also the code that deploys it is not going to be messing up the environments or whatnot? The deploy code pattern becomes the best approach to it. Naturally, for large language models and even for large deep learning models, this might not be the most suitable approach or practical approach, because the cost of training again and again in different environments becomes significant, and the availability of the data in dev environments that mimic the production grade properties might not be available for the purposes of building an LLM or one of these large models. And Obviously, hyperparameter tuning is key to performance. Like I said in the previous slide, AutoML is something that you should dig deeper into on your own. It might be of help in this step. Then we spent a bit of time on understanding what does CI/CD really mean for ML. I think this part of the uh, discussion is usually something that most data scientists really gloss over. They don't spend as much time on this, and then what ends up happening is in practice they have hygiene problems with their code. So please follow best practices. I think that's the one of the purposes of discussing these topics in depth during the uh, middle of the course in those weeks. Let's summarize it. The Git flow pattern is a very useful pattern of how you manage code repositories, because otherwise the number of options, the flexibility is quite significant, and you might get lost for um, choices, right? You might have so many options, so many ways of doing things that as an organization you might have multiple different instances of how code is managed, and that becomes quite challenging in governance and in ensuring that the right organizational practices are adopted. So the best approach is just to have one single way in which you work with code, and that's using Git flow. And within the Git flow pattern, you've got these branches of high sanctity. um, like for instance, the branch that deals with the uh, final version in production, the branch that deals with certain releases of code at a particular point in time, etc. So follow Git flow, and along with the deploy code pattern of how code moves across the environments, you've got now an ability to take code and ensure that you've got full traceability from when the code is developed to when a particular model gets deployed to a specific environment or a specific production use case. And coupled with containerization, especially using Kubernetes, and the automation around CML, with or without GitHub Actions, like most people uh, work in small enough setups that GitHub Actions becomes extremely powerful and usable. But there will be a few of you who work in companies which have enormous amounts of data or have under enterprise scale regulations, in which case you might not be able to put your entire CI/CD pipeline on GitHub. But nevertheless, you'll have something equivalent in-house, like a Jenkins, which is hosted on a CI server locally or in your own private cloud on private endpoints on AWS or Google Cloud or whatever. Um, the principles remain the same, which is you try to use CML, you try to use automated actions to get these deploy code patterns implemented, along with Git flow as the best practice usage of Git as a repository. That will give you a really solid way in which you can manage ML models, right? So you've got continuous integration, which takes care of testing as and when new code gets built. You do this into a feature branch, and the feature branch becomes the vehicle that gets promoted or not based on satisfaction conditions, right? Which is like in terms of model performance or in terms of unit testing results, because there are specific features or specific bugs that are getting fixed, right? And then when you're ready, then you raise a request or a pull request to merge it into a main branch or a develop branch, and then the approval process goes through the checks and balances which are required, typically done by a human like a senior engineer or an ops engineer, and then they merge it with develop, and then the CD pipeline runs to take this model and put it into staging. Once in staging, you've got this automation which will automatically hyperparameter tune, automatically select the models, because now you've got access to bigger data sets than what you had in dev. So there's no human involvement, but the automation allows you to create a version of the model that works in staging, and then verify the outputs. Again, CML or GitHub Actions plays a useful role. You take those outputs, you see whether the performance of the model is satisfactory. Is it worthy of being a challenger? At which point you raise a pull request, and then you try to get that merged with the main or the release branch, whichever is the target that you're building this towards. Again, a manual approval process happens, right? And then the CD pipeline runs in production, and then the actual challenger and model gets built. Again, you do a sanity check on the performance, because hopefully by now the performance variation will not be significant. There might still be some, because production data is definitely the gold copy, and that step then concludes with the challenger model being selected or being declined, and then you've got the entire load balancer which setup which takes both these models and runs it in production. And at some point you have a gate where a human takes a look at the overall performance of both the champion and the challenger and decides that yes, it's time to promote the challenger as a champion. And that act of promotion also should be governed, right? Which means it happens on, let's say, MLflow UI or whatever AI platform that you use for operations. So in essence, this slide is also a very good ready reckoner of how you go about building ML, the entire development cycle, right, from across the environments using the best practices of Git flow. Finally, once you've got the model running and things are in production, your work doesn't stop there. You've got to do the actual work of operations in production, and that's where the monitoring, observability, and response really comes into play. Of these three categories, response is usually not under your control. It's with IT support or enterprise support, tech support, and they decide what the different steps are, what the triaging process is, etc. You can aid in the process by giving the right information, and that comes from not just knowledge sharing about what you've built, but also the information about what logs and how to read those logs, what salient pieces of information to look in the logs. So that comes from monitoring. Matrices and logs are a very critical aspect of what you monitor. So you've got to instruct the tech support team to help them make the right choices. Then observability is a very critical aspect of it. Hopefully you can work along with your DevOps team or a cloud ops team to ensure that the right observability tools are built into the entire deployment model. So that's with respect to the operations that need to happen after a model goes live. And then finally, you've got to always pay attention to security and obviously aid in the overall governance of the entire infrastructure of the entire model. Um, we spoke about various aspects of security and governance. So you've got to start from the beginning, which is where the data is actually curated and brought in. So if you don't have the right set of data, or if you don't have trustworthy data, like we saw with the poisoning assignment in one of the later weeks, you will have problems with the model which you may not even know about, right? So ensure provenance is there. The provenance ensures in turn that the data is trustworthy, and therefore you don't have any um, malformed data which is deviating from what the model should actually be doing. Robustness of the model is a consideration that you'll have to give it the passage of time to ensure that it's actually consistently producing results across variations in the data. Model confidentiality, ensuring that you're not leaking any sensitive information. Inference time security is also very important. You don't have to, you know, uh, reinvent the wheel. Think of it as, yet another software which is serving APIs or endpoints. But for models specifically, you've got to be careful about what you allow for information to be passed out and how many times you allow requests to come in. Because, like we saw with the model inversion attacks, if you allow sufficient amount of traffic coming from the same IP address or same source, they can look to reverse engineer by perturbing the input space slightly and getting a flavor of how the outputs change. Then the model deployment process itself has to be secure, which doesn't just mean that the code is built with secure practices, but also the automation ensures that the keys and secrets that are necessary for two cloud services to interact are maintained in a way that's secret. And then the model is deployed in a way that's hardened so that the containers are not compromised, etc., etc. Then compliance, governance, explainability go hand in hand. The tools required for it is something that you'll have to build into the automation right at the development stages itself. We saw that example with SHAP and um, yeah. Then model monitoring and drift detection. That's a continuous activity once the model goes into production. All right. So with that, I'll stop. I hope that gives you a summary of the salient best practices in the course. I think the individual weeks themselves go into the details that are necessary. So you can always use that as a reference. In the next video, we will dive into some of the emerging topics in this field. I'll see you there.